Hello. So yeah, this isn't really a talk, it's more just a kind of mess of things that I'll be playing with. I'm going to be talking about, well, in fact, let's ask a question first. Let's ask, just a kind of discussion, what we think the greatest invention of the last 100 years is. What's the right go? Yeah, no, I'm not sure that's even top 10. Anything else? Internet's pretty good. It's probably 2 or top 3 maybe, second.
Internal combustion engine.
Yeah, that's pretty good. That's pretty good. It's definitely top 10. But no, sorry, yeah.
Electric guitar?
Yeah, electric guitar's very good. Very good indeed, but still wrong. These are all good but wrong. The greatest invention in the last 100 years is in fact the Web Audio API, which I'm going to be talking about a lot. The Web Audio API is simply amazing. If you don't know what it is, it's a way of processing audio, a kind of high-level way of processing sound directly in the browser. And let's see, I don't even know. Right, so this is the kind of, talk a bit about sound first in case you're not kind of an audio expert or just a kind of high-level thing. So this is people do this a lot in talks, they have a dictionary definition of things that they can't really articulate very well themselves. And this is the dictionary definition of sound, which is vibrations that travel through the air or another medium and can be heard when they reach a person or animal's ear. That animals thing makes me laugh for some reason. It's just or an animal, not robots or any other thing, just animals. So, this is Douglas Crockford. I don't know if you know Douglas Crockford. He's the kind of Mr. JavaScript. He works for PayPal now, which is strange. So I'm just going to use this slide to kind of demonstrate the basics of audio. So sound is essentially made up of sine waves. Sine waves all kind of, that's a sine wave there. So it's it's the most basic, pure type of sound. And sine waves combined together in certain ways makes all sounds. It can be deconstructed. So when dealing with audio, there's kind of 2 basic things you have to deal with. There's frequency. If I put the frequency up, you can see that. That's it's the kind of the closeness to the waves, the number of waves per second. Frequency is the number of measured in hertz. It's the number of waves in a second. So a lower frequency will be that's a kind of bassier sound, and it's kind of drawn out and so high pitched. You also get amplitude, which is how loud a sound is. That shrinks the wave down. Something's quiet, it's not as big. I mean, if it's too loud, Douglas doesn't like loud sounds. Okay, so you also get different types of waves. So sine waves, there's kind of basic types of waves. You get square wave, which is exactly how it looks. And so that kind of wave sounds different. Different looking waves sound different. That's a kind of basic principle. Okay, so the Web Audio API uses this thing called a node graph, and basically it's the way I kind of tend to explain it is if you were to play like an electric guitar or something, you would have your guitar, you would take a lead from your guitar and you would plug it into maybe like an effects pedal, like a distortion pedal. You would take another lead from that pedal and then you'd plug it into either another pedal or an amplifier. So this kind of chaining effect, and that's exactly how the Web Audio API works. It's this individual nodes that you connect together to make more complex kind of things. So, yeah, let's just do a little demo. I'll try and nail down so you can see it. So, right, okay, I'll use this keyboard. Okay, so, just clear that, don't want to see that. Okay, I'll bump up this. Okay, so, the first thing we do with Web Audio API, we have a thing called a context. And that's like, basically how, any of you use like Canvas? Yeah, no, Canvas. So like Canvas has its own thing of context, and sort of like context is a kind of your world of sound that you paint onto. That's very peppy. But that's the basic premise. So we can do this new WebKit audio context now. That's because I'm currently using Chrome, but the Web Audio API is available in other browsers. It's available in Chrome, Safari, Firefox, recently Opera. That's all the browsers, isn't it? That's all of them. Yeah. Yeah, so all the browsers, available in all the browsers. Okay, so we create this thing called a context, which is your world of sound, okay? And let's just create an oscillator. So an oscillator is like, just like we were saying with the sine wave, or a square wave, it's this kind of generator of sound that just repeats a wave over and over and over again, okay? So we do that by doing context.create oscillator like that, okay? That's just lovely. Then we want to connect that oscillator to our speaker. So we just do connect, like we do with when we're talking about taking a wire from one thing to another. And then we do context.destination, and that is, context.destination is the speakers, your output from the browser or whatever. And then we can just do start. We start this off, and we want that to happen after immediately, so say 0 seconds. And hopefully, fingers crossed, we should hear. Look at that. That's just lovely. So that is making sound completely in the browser. That's from scratch. There's no plugins there, nothing fancy. It's just native to the browser. It's pure JavaScript. It didn't download anything. It's fantastic. So the other thing you can do, I mean, you can so we can change the type of those waves. You can have a square wave and triangle waves. These are basic types. They come predefined with Web Audio API, but you can generate anything you want. So David Bowie used basically which is a xylophone. A xylophone is just a little keyboard that plays square waves at different frequencies, so different pitches. So yeah, so obviously the first thing you do with the Web Audio API is to make one. So this is and that's just basically a different div with, assigned to a different frequency, and that just generates and plays, and you can make little tunes. There's a tutorial on how I made that there. If you care, you can probably just do a search for Web Audio xylophone. There aren't many of them about. So yeah, the other thing you can do. So the Beach Boys. There's Mike Love. He's the Beach Boy no one likes. He tried to fire the rest of the Beach Boys, even though he didn't write any of the songs. Well, he wrote some of the songs, but he wasn't the main guy. Yeah, no one likes him. And he's playing this thing called an electro theremin here, and this is slightly different than a theremin. You kind of wave with your hands like this, but this one is essentially a sine wave, like we just played earlier, and you can just slide to different frequencies. And this is on good vibrations, like this. The thing goes to. That's basically just a sine wave, like we played there. So obviously the next thing you do is you make a theremin in the browser. And I'd like to give you a little demonstration, a little performance of that right now, with my accompaniment.
Space, the final frontier. These are the voyages of the Starship Enterprise. Its 5-year mission, to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before.
Thank you very much. Thank you very much. Yeah, so endless fun. Okay, so there's other things you can do with this web audio API. It's not just basic sine waves. You can create kind of more complex systems. I'll just do that demo again. Let's think. So context. I'll just do this quickly. New web character audio context. So I'm just going to repeat this. Or oscillator equals context. Okay, so the other thing we can do, you can see that you get things like, there's loads of different types of node, right? Okay, and so different nodes do different things. They process the audio in different ways. So we can create something to manage the volume. So we can do context.create gain. And that basically changes the amplitude, the volume of the audio. And so we'd, using the wire analogy again, oscillator.connect, and we connect it to our volume node. And then we take the volume node and we'd connect that to the speakers. Okay? So that's us all chained up. Let's make it a square wave. So we do os.type. We can just do square, like that. So that'll be a different type of sound. That'll be like the, in fact, let's make it a triangle. Let's be fancy. Right, so the other thing we can do, it's not just a simple, here's a sound, and there's not a sound. We can kind of be fancy with our timings. Each of these types of node have parameters which can be scheduled in different ways. So an example being, what we could do is we could do linear ramp to value time. Okay, so what this is saying is, let's see, I'll talk about time later on, so we'll just skip that and again, linear. I'll explain this in a second. Oh no, oh no, oh no.
Just use the mouse.
Yeah, I could use the mouse. Where's the mouse? That's it. Let's see, start. Okay, so what we're doing here is we're telling the oscillator to start, but then we're saying we're scheduling different values of the gain node at different times. So what we're doing is we're saying at context.current time is basically now. So we're saying now make the volume 0, and then over the next 10 seconds from now to 10 seconds in the future, just kind of ramp that volume up to 1, which is the kind of the default level for that. So hopefully if I do this, it should fade in over 10 seconds. Yeah? Is that too loud? Cut that off. Ah, okay. Sorry. Hey, there we go. Okay. So, we've got so much, the point there is we've got so much control over this. There's filters, compressors, there's all these different types of node, and they all have these parameters that we can kind of schedule and do fancy things with. So here's an example of something that's more complex. You can have different types of oscillators, or even, we can use audio files as well. I'm using kind of oscillators to avoid the kind of the loading in things, but there's loads of things we can do. We can change the shape of waves and add reverb and compressors and things like that. So the interesting thing about this is when your audio comes into the Web Audio API, you can basically manipulate it. If you imagine the sine wave, you can imagine just a huge array. You know, it's like and each of those elements in the array, they have a slightly different value, a slightly different volume. And that's how you would map a sine wave. You'd just such a huge array and it would just go like that at different values. So because we have that, we can kind of flip those values around and kind of create new sounds. So I made something a little bit more complicated, and this is a synth. So this has, like, you know, these oscillators. We can change the shape of the wave that we saw earlier. It's got a whole bunch of other things like attack and just like attack decay, to say the least. If you don't know what attack is, like like we saw with that oscillator fading in, it's like the attack is like the ramp up of your initial sound, decays and it goes down, sustains how long the sound hangs around for, and releases the kind of rate it kind of fades away. So yeah, is that too loud or is that okay? So there's all, you know, so we can change these kind of waves and make them different frequencies and yeah, so it's like, you know, there's all this kind of, you know, you can basically spend hours just making nonsense. But the interesting thing is this is, you know, this is, again, all in the browser. This isn't any, there's no fancy plugins, there's nothing being downloaded, there's, you know, and this is kind of, we've never had this before. We've never had this freedom to create sophisticated, well, you know, slightly sophisticated, fairly crude audio apps in the browser. Okay, so next. Oh yeah, if you want to make your own synth, I made this project. It's called QWERTY Hancock, and it's basically allows you to add a keyboard to your own audio project. It takes in keystroke keyboards. And did I turn that? Oh, it's not working. But yeah, so you would basically hook that keyboard up to your own synth or whatever you decided to make, and you can customize a whole bunch of stuff. Yeah. Okay. So timing. I say a lot. Timing. I remember making a drum machine using the pre-web audio API, and they would use set timeout. So I don't know if you know that set timeout's actually not very accurate. so you can use set interval, set timeout, and it's a way of kind of scheduling things or timing things or repeating things after a number of seconds. But what's interesting about the amazing web audio API is it has its own timing system, its own scheduling system. I don't know what these errors are. Okay, so if we do, let's create a context again. We're all good at creating context. WebKit audio context. That's, if you're using Firefox, that's actually unprefixed, prefix free, so it's just new audio context, which is brilliant. Oh no, maybe I've done too many. Do this with this.
Might need to refresh the page.
Yeah, I think I did. Oh no. Yay! Okay, so we have to create. Sorry about this. We don't have to connect it to anything. We can just start it off. Okay, so context.current time. Oh, sorry, it's not functional. Current time. So if I just keep doing that, that is basically the number of seconds since you kind of activated that context, and it's crazily accurate. You can schedule things and not have to worry because it runs on a separate thread to your main kind of your browser window. So this is great because we can say to schedule something in the future, we can just say take the current time and add 10 seconds to it. So do something 10 seconds in the future and it'll do it exactly 10 seconds from now. Okay, so by doing that, let's do, we do another thing. If you go to beatpetite.com, this is a drum machine. And so that timing's, rock solid. It's perfectly in time, and these aren't drum samples I'm using. These are actually the sounds you're hearing are created using the Web Audio API. So I've created for that hi-hat, for example, that's basically white noise that I've filtered to sound like a hi-hat. And you can see that if and there's no kind of stutter there whatsoever. It's clean. Okay, so timing is flawless, and that is another brilliant thing about the Web Audio API. Okay, right. The other amazing thing about the Web Audio API is this get user media. How many of you use get user media? Yeah, most of you know what it is. It's kind of fairly obvious from the title. It allows you to get the user's media. Yeah, so let's say open up, what we're going to open up. Let's do. Okay. What am I going to do? Let's open that, and I'll do it full screen. Oh yeah, okay, so I guess like you, well, like most of you, you spend your time pretending you're talking to David Bowie on Skype, which I do a lot. And so when you use the get user media, you get this little, to get your microphone working, you get this little thing that this website wants you to use your microphone, okay? So go, there's David Bowie. That's coincidence, he's on Skype. So, hi David, do you hear me? Hello? Oh no, he's not working. Hello? It's a bad connection, David. Hello? Oh no, come on. Hold on. Oh no, I've got one. Oh, David. Sorry to keep you waiting, David. Hello? Hello? Hi, David. Hello there, Glasgow. Are you alright, David? You're looking quite pasty. Yes, I'm okay, thank you. Has anyone got any questions for David? While he's here, you can't really. Anyone?
Who's your hairdresser?
My hairdresser is my next door neighbour. David, will you be using the Web Audio API on your next album? Yes, of course I will, thank you. Okay, thank you for your time, David. Goodbye. Yeah, so David Bowie, everyone. Right, so that was David Bowie there, that was nice. So that was a microphone straight in. There was no, it wasn't actually David Bowie, sorry. In case you were confused there. It was me with the microphone. I don't know if you saw, but that is straight in. There's no plugins. That is me using a microphone straight into my laptop. nothing, didn't have to install anything, there's no extra hardware there. And that, again, is great. So the other thing you can do, you don't have to just use a microphone. If I take this out, and let's think, we have a guitar just handily sitting there. I don't have a plectrum, so I'm using a SIM card. It's disposable technology these days. Yeah. So let's do a spunky guitar. Okay. So this is a guitar amp. In the browser, again we get this little pop up. Oh, look at that. You can get some volume. Okay. Ah, lovely. Nice and tune. Just as when I bought it. Okay, so this again is nothing. There's just a guitar straight here, straight into the laptop. You play all the classics. Yeah, Team Spirit. No? Okay. Something like that. Okay, so maybe you need some distortion. Okay, so again, like I was saying before, we have this the array and the waveform, and we're just messing about with it. So we take a massive array and just kind of mess with the levels in the waveform. We can add distortion. So I like the bit So that is again, let's call that this. Oh, yeah. Straight in, and you can see here. This is the waveform. The kind of live waveform. This is so you can do like real-time analysis of audio in the browser as well, which is fantastic. The other thing. So what we can do is so we've got this array. This big massive array, and we know all the values in it and with the sound. So what we can do with that array is we can actually figure out the note that's being played. We can figure out the frequency and the pitch of the note that's coming in. So because of that, we can then connect that to the synthesizer we saw earlier. If we just click this. So basically, you could kind of see that was kind of working. Being able to kind of take the note from that is an absolute racket. I have to agree with that. But we're taking the audio there and it's kind of messing around. Okay, so let's close that immediately. Right. Now, something more sensible. Okay, so. The other thing that's even more exciting about this, the Web MIDI API. So what's happened in just over the past year is this thing called the Web MIDI API. Does everyone know what MIDI is? Kind of know what MIDI is? It's like a way of, it's been around since I don't know what year, 1980? I don't know. That allows you to, it's basically what all hardware, keyboards, synthesizers, various instruments use. It's a kind of protocol that allows, when you press a key on a keyboard, it'll send essentially a number of what key was pressed, and then the kind of software or hardware on the other end will be able to play a sound depending on that. And so MIDI is kind of wildly popular. It's basically if you buy any sort of musical instrument, any sort of keyboard or anything today, it will have MIDI. And the Web MIDI API allows us to take MIDI from, so this is just a little keyboard. You There's no sounds in this, it's strictly just a MIDI keyboard. And if we go to, let's do localhost synth. Hey, so we have MIDI. So, okay. So this is me getting audio from a hardware device, which is pretty cool, because working with the web a lot and stuff, we don't really deal with a lot of hardware. And again, that is just USB straight in. I don't have to configure anything or anything. So, probably sick of performances. Michael, could I borrow you for a second? Okay. Can I get you just to go like that? Yeah. Thank you, good. I don't know what I'm doing. You ready?
Yep.
You nervous? Alright, hold on that drum. Oh, I can't do it. I don't know what I'm doing. Thanks, everyone. I told you to learn it. Okay. So, okay. So, even if music's, what I'll do is, basically why would you want to do all this? I completely understand if you're looking at this as, this isn't a talk, this is just nonsense. So, if you've no interest in music whatsoever, if you've no interest in making instruments in the browser, then the Web Audio API is great for, say you make games. Games are going to be transformed by the Web Audio API. It'll basically allow you to add reverbs or seamlessly add effects or be up to the millisecond response times to, like, if something happens in a game, and you'll be able to crossfade sounds and merge them easy. And yeah, it will change everything. You might think this is silly. It is a bit. But the other thing, when we're talking about MIDI though, is that MIDI isn't simply about keyboards. A lot of lighting systems use MIDI. MIDI's a protocol that's used elsewhere. So if you wanted to kind of control lights directly from the browser, you can now do it. And there's this, with MIDI API, we're going to see a whole bunch new hardware. I don't know what I'm trying to say really. We're going to see a whole bunch of new hardware interacting directly with the browser, which we've never really seen without using sort of kind of intermediate plugins. Right, which again is fantastic, and thank you. Any questions?
What does a MIDI signal look like? Can you serialize it?
Yeah, so basically, it's basically just like a string of numbers, and that's coming in, and basically I'm just taking what number it is and changing it to play this oscillator at this frequency when you match a string of number 68. So yeah, it's great. Yeah.
So does it support a full set of MIDI commands? Because there's ones for sustain and sort of...
Yeah, so everything, I know that's kind of basic one, kind of shown there with that, but it's the full everything. It's not just notes, it's all your parameters and all your fanciness. Yeah, so that's pretty cool.
Is this available in current browsers?
Yes, yeah, so the only... Yeah, like all the browsers. Microsoft haven't committed to implementing it yet. But yeah, like I say, so it's Safari, Chrome, Firefox, Opera. And I should say it's in mobile Safari as well, and mobile Chrome. So you can do it in your mobile browsers. as well. Yeah, good.
You say that you can control lighting systems. Is this a replacement for commercial stuff like a DNX protocol, or just for in the house and controlling the
I don't know. Someone just said to me once, "Oh, you can use MIDI for lights." I'll use that in my talk. Yeah.
Can you use the timing as a replacement for the set timers? Is there any callbacks? Or is it just getting the number?
No, it's just getting the number. What you could do is this would be really be really hacky and pointless. But you could set an analyzer to analyze the volume of the wave at a certain time. Then you could say when it's at a certain level, then you could fire it. But that's just silly. I think there is another timing protocol though, which I don't know what it's called. I'm sure is it performance or something? Does anyone know about that? I'm sure there's another timing system that's not audio related that's on its way.
Is there limits to the polyphony?
No. No, so what I'm doing is each, like when I'm creating oscillators, they're really cheap. So anytime a key is pressed, I'm creating a new oscillator from scratch, and then it just gets chucked afterwards. So you can create as many oscillators as you want. I'm not sure, there probably is some sort of channel limit that I'm not aware of off the top of my head. But, yeah. Yeah.
For audio input, does it support quantization or?
Not that I know of. I think you'd probably have to write that yourself.
Right, you need to write a program for.
Yeah.
And what about for MIDI? Does it support like going to the nearest quarter note or eighth note? Or?
I don't know. I don't know. Right. Yeah.
I see how when you're setting the attack, decay, sustain stuff, is that like you assign them as individual attributes, or is it?
Yeah, so it's a parameter that you say, like I was showing you the linear ramp to at time. So like your attack, I'm just doing that same thing. I'm saying when you press the note, take 5 seconds to get to that volume. So yeah, there's lots of stuff you can do with that. Yeah.
Any way to kind of save what we produced?
Yeah, so there's a library called recorder.js, and basically that creates a kind of special node, like I'm showing you, and if you, rather than connect it to the speakers, if you connect it to this node, it will give you, I think it actually supports different file formats, so you can download what you've created. Yeah. And that's great, thank you very much. Thanks for coming. Thanks to Michael.